Hi, Intro to Calc. This is section 5.6. This is our last video and last piece of new information before the end of the school year. So recall the integral from a to b of f of x dx is equal to the net area. So we spent a lot of time last week and the week before finding areas of trapezoids and triangles, and some were positive and negative. And so that was the net area on an interval. And because we've also talked about another way to consider the integral is that it's equal to its antiderivative, this represents the change in the accumulation function, or the change in that antiderivative. This is called the fundamental theorem of calculus. And this allows us to do a lot of things. So the integral from a to b of f of x dx is equal to the antiderivative evaluated up high minus the antiderivative evaluated down low. By low and high, I mean these integration bounds that we've had on our integrals in the past. So number one, evaluate the following: the integral from 1 to 3 of 5 dx. So I'm going to first start by finding my antiderivative. So my antiderivative is 5x plus c. And then this is the classic notation that says I found the antiderivative, but I still have to wait on evaluating. I haven't plugged in these numbers just yet. And then I plug in 3. And then I have to subtract plugging in 1. So we get 15 plus c minus 5 minus c is equal to 10. So there's one thing I really want us to see here. Well, I should say two things. One is this process, that you find the antiderivative, just as we've been working on in the past, and then you evaluate it at these bounds. And it's important to subtract those values. The other thing is that this plus c no longer mattered because you're finding the change in the antiderivative. So you're going to always be adding c and taking the c away. That when you're evaluating these integrals, it's not important. The only time that plus c is important is when you're finding the particular or the specific antiderivative. So what it exactly belongs to is when the plus c becomes important. Number 3. The integral from -2 to 4 of 3x squared dx. So 3x squared has an antiderivative of x cubed. Still waiting to plug in the bounds. And now you make your substitution. Being real careful with parentheses here. So 64 minus a -8 is equal to 72. Number 5. Find the antiderivative of each of these. So we have x cubed over 3 minus 6x squared over 2. Evaluate from 1 to 3. So 3 cubed over 3 minus 3 times 3 squared. That's plugging in 3 to each of these terms, minus plugging in 1. 27 over 3 is 9. 3 squared is 9 times 3 is 27. Minus 1/3 plus 3. This becomes -46/3. You can use a calculator to simplify that. Number 7. Sine x has an antiderivative of negative cosine, and we evaluate from 0 to 2 pi. The cosine of 2 pi is 1, so this becomes -1. The cosine of 0 is also 1, so this turns out to be 0. So there's no change on sine x on the interval 0 to 2 pi. Graphically, this makes sense, and it connects to what we had learned before, that if here's 0 and here is 2 pi, the net area is just 0. And the last problem, I'm going to take a second and rewrite as x to the -1/2, and now use the power rule for antiderivative. So I'm going to add 1, so it's x to the 1/2, divided by 1/2 is the same as multiplying by 2. And then you evaluate from 16 to 25. So 2 root 25 minus 2 root 16. You do the up high one minus the down low one. 2 times 5 is 10. 2 times 4 is 8. So our answer is equal to 2. For homework, I want you guys to go back to the 5 questions that are on the right-hand side. So these are all the evens. Bye.